Revolutionizing AI, Extropic AI secures $14.1 million funding for groundbreaking accelerator chip development. Overview and key developments. In a significant advancement for the field of artificial intelligence, Extropic, a San Francisco-based startup that specializes in physics-based computing, has successfully completed a $14.1 million seed funding round. This funding will be directed towards the development of innovative accelerator chips that leverage thermodynamic principles to enhance generative AI capabilities. Founded in 2022 by Guillaume Verdon, Extropic aims to redefine computation by integrating generative AI with the laws of physics, moving beyond the limitations of traditional digital hardware. Funding round details. The seed funding round was spearheaded by Kindred Ventures and saw participation from an impressive array of investors, including Buckley Ventures, HOF Capital, and several notable angel investors such as Aidan Gomez Cohere and Balaji Srinivasan Coinbase. This financial backing is poised to accelerate Extropic's efforts in advancing its unique thermodynamic computing technology that addresses the inefficiencies of current digital systems in managing complex probability distributions crucial for generative AI. Technological approach. At the heart of Extropic's innovation is its focus on out-of-equilibrium thermodynamics. This approach allows the company's chips to execute probabilistic computations in a manner that traditional digital hardware cannot, thereby enhancing both speed and energy efficiency. Current AI systems are often bogged down by the need to manage large datasets and memory, creating inefficiencies. Extropic's chips aim to physically execute these computations, unlocking faster processing times and reduced energy consumption. The company has already made considerable progress, fabricating a prototype of a superconducting processor and developing room temperature semiconductor devices intended for broader applications. This foundational technology is expected to serve as a catalyst for a new paradigm in AI acceleration. Team composition. Extropic boasts a team of experts with diverse backgrounds in AI and physics, including alumni from industry giants such as Google AI, IBM, and NVIDIA. Guillaume Verdon, the CEO, has a rich history in quantum technologies and AI, having previously led initiatives at Alphabet's X. Trevor McCourt, the CTO, brings a mechanical engineering perspective to the team, having played a crucial role in the development of quantum programming software. This interdisciplinary team is uniquely equipped to pioneer this new approach to computing, focusing on the convergence of generative AI and natural physical processes. Vision and future goals. Extropic envisions a future where computing transcends traditional boundaries, utilizing natural entropy as a resource rather than something to be suppressed. The company aims to create systems capable of autonomous learning and adaptation, achieving computational efficiencies that can scale generative AI applications without a proportional increase in energy consumption. This vision addresses the growing demand for AI computational power while also considering sustainability. Timeline of events. 2022, Extropic is founded by Guillaume Verdon. March 2024, the company emerges from stealth and releases a light paper detailing its innovative approach to thermodynamic computing. December 4, 2023, Extropic announces the successful closing of its $14.1 million seed funding round, marking a significant milestone in its development journey. Differences among sources. While all sources highlight the importance of the funding and the innovative nature of Extropic's technology, some nuances emerge. Source 2 provides a detailed technical overview of the computational paradigm and its implications for generative AI, whereas Source 3 presents a more visionary narrative about the company's goals and potential impact. Source 1 could not be accessed, limiting broader insights from that source. Conclusion. Extropic's advancements in physics-based computing represent a transformative shift in AI acceleration. By harnessing thermodynamic principles, the company aims to overcome current computational limitations, paving the way for more efficient and powerful generative AI systems. The recent funding will be pivotal in realizing these ambitions, potentially reshaping the landscape of AI technology in the years to come. In summary, Extropic's journey illustrates the intersection of physics and artificial intelligence, suggesting a future where computing not only mimics but also collaborates with the natural world. As the company forges ahead with its groundbreaking technology, it stands at the forefront of what could be a new era in AI development. Counterintuitive information in the content. 1. Harnessing entropy. The premise of using entropy, often viewed as a disorder or a loss of energy, in computing is counterintuitive. Traditional computing paradigms aim to minimize entropy to enhance reliability and precision. Extropic posits that by leveraging out-of-equilibrium thermodynamics they can actually use entropy as a resource rather than something to be controlled. This suggests a radical shift in how we think about computational efficiency, wherein embracing disorder could lead to more powerful and efficient systems. 2. Physical computation versus digital. The article suggests that Extropic's chips can perform computations physically and natively as opposed to current digital hardware, which struggles with the inefficiencies of data movement in memory. This challenges the established notion that digital computing, which relies on binary processing, is the most efficient method available. It raises the question of whether the future of computing may not just involve faster digital processors but entirely new physical paradigms. 3. Self-programming systems. Extropic's vision includes computers that can naturally find a way to program themselves. This contradicts the traditional view that programming requires explicit human intervention and structured coding. The implication is that future AI systems could autonomously adapt and evolve, potentially leading to unexpected behaviors and capabilities that cannot be easily predicted or controlled by their creators. For reimagining energy needs, the claim that Extropic can scale generative AI without proportionally increasing energy production is a bold assertion that contradicts the common understanding of computational demands. As AI systems grow in complexity and capability, they typically require more energy. Extropic's approach challenges this assumption by suggesting that energy efficiency can be achieved through innovative computing methods rather than sheer power scaling. 5. Interdisciplinary team composition. The fact that the team's background spans both AI and physics, particularly from quantum computing, implies that the solution to generative AI challenges may not come from traditional computing methods or solely from advancements in AI algorithms. This could lead to a paradigm where breakthroughs in physics directly inform and enhance computational methods, which is a departure from the typical separation of disciplines in technology development. 6. Timing of development. Extropic emerged from stealth mode in March 2024 and immediately closed a substantial funding round in December 2023, suggesting that the development timeline is significantly compressed compared to typical hardware startups. This rapid transition raises questions about the feasibility and maturity of their technology, which may be perceived as overly optimistic given the usual timeframes associated with hardware innovation. 7. Role of noise. The emphasis on using noise as an asset rather than a liability in computational systems is counter to conventional wisdom. Typically, noise is seen as a detrimental factor in computing, contributing to errors and inefficiencies. Extropic's approach suggests that noise could be harnessed to create more adaptive and resilient systems, which is a significant departure from traditional engineering principles. 8. Self-organization inspired by nature. The idea that future computing could mimic self-organizing processes found in nature defies the conventional view of computers as strict rule-based systems. This notion implies that future systems could evolve in ways that are not entirely predictable or controllable, leading to ethical and practical challenges in how we deploy such technologies. 9. Critique of current AI paradigms. Extropic's assertion that current AI systems inefficiently manage data by spending too much time on memory operations challenges the notion that existing technologies are sufficient for the future of AI. This critique suggests that substantial disruption is necessary in the field to achieve the next level of advancement, which counters the incremental improvement mindset prevalent in much of technological development. Each of these points reflects a fundamental rethinking of established norms in computing and AI, suggesting a transformative shift that could redefine the landscape of technology in the near future. Important content overlooked in the report: the paradigm shift in computing and its broader implications. While the report provides a comprehensive overview of Extropic AI's recent funding and its innovative approach to AI acceleration through thermodynamic computing, there are several critical elements that many readers may overlook. These elements are significant not only for understanding Extropic's technology but also for grasping the broader implications of their work within the context of the evolving landscape of artificial intelligence and computing. 1. The concept of out-of-equilibrium thermodynamics. One of the most profound aspects of Extropic AI's approach is its reliance on out-of-equilibrium thermodynamics. This concept is pivotal because it signifies a fundamental shift in how we perceive computation itself. Traditional computing relies heavily on equilibrium states to perform calculations, which can be limiting in terms of efficiency and speed, especially for generative AI that deals with complex probability distributions. By leveraging out-of-equilibrium conditions, Extropic's chips can perform probabilistic computations that are more aligned with the natural processes of the universe. This approach not only enhances computational efficiency but also introduces new possibilities for self-organizing and adaptive systems. The significance of this shift cannot be understated. It suggests a future where computing can evolve alongside natural processes, potentially leading to more robust and intelligent systems. This is an essential point that many might overlook, as it lays the groundwork for a new era of computing that mimics biological processes. 2. The team's unique interdisciplinary background. The report highlights the team composition, which includes experts from various fields, particularly physics and AI. While many readers may acknowledge the team's credentials, the importance of their interdisciplinary background should not be underestimated. The convergence of knowledge from physics, AI, and quantum computing is crucial for the success of Extropic's ambitious goals. This unique blend of expertise allows Extropic to approach problems from multiple angles, fostering innovation that a more homogeneous team might miss. The transition from quantum computing to thermodynamic computing represents a critical pivot for many scientists and engineers disillusioned with the prolonged timelines of quantum technology. This shift reflects a broader trend in the tech industry where interdisciplinary collaboration is increasingly recognized as a key driver of innovation. Readers should appreciate how this team dynamic can lead to breakthroughs that fundamentally alter the trajectory of AI development. 3. Vision of autonomy and self-programming. Extropic's vision extends beyond merely creating more efficient chips. They aspire to redefine the very nature of computation. The idea of building systems that can learn and adapt autonomously without relying heavily on predefined programming is a significant leap forward. This concept ties back to the discussion of entropy, where instead of suppressing natural processes, the technology aims to harness them. The implications of this vision are profound. If successful, it could lead to AI systems capable of self-improvement and adaptation in real time, vastly outpacing current models that require substantial human oversight and intervention. Such advancements could alter how industries operate, affecting everything from healthcare to autonomous vehicles. This transformative potential deserves more attention than it receives in the report, as it opens up discussions on the ethical, societal, and economic impacts of autonomous AI systems. 4. Environmental considerations and energy efficiency. Another critical aspect that may be overlooked is Extropic's commitment to achieving high computational efficiency without a corresponding increase in energy production. As AI technologies continue to proliferate, their energy demands have raised concerns about sustainability and environmental impact. Extropic's approach directly addresses these concerns by aiming to create a computing paradigm that is more energy efficient. This focus on sustainability is increasingly relevant in today's context, where the tech industry faces scrutiny over its carbon footprint. By developing chips that utilize the principles of thermodynamics, Extropic is positioning itself as a leader in green technology within the AI sector. Readers should recognize the significance of this commitment. Not only does it align with global sustainability goals, but it also sets a precedent for future developments in AI and computing that prioritize ecological responsibility. 5. Investor composition and market implications. The diverse group of investors backing Extropic, including notable figures from various successful tech companies, reflects a significant vote of confidence in their approach. This investor composition is more than just financial backing. It highlights a growing recognition within the investment community of the need for innovative solutions to the limitations of current AI technologies. The significance of this funding extends beyond Extropic itself. It indicates a shift in the types of technologies that investors are willing to support, favoring those that challenge conventional paradigms. This could influence market dynamics, encouraging other startups and established companies to pursue similar paths toward integrating physics and AI. Understanding this shift is crucial for stakeholders across the tech landscape, as it may herald a new wave of investment in physics-based computing technologies. 6. A new era of generative AI. While the report mentions Extropic's goal to enhance generative AI capabilities, the broader implications of this enhancement are worth exploring in greater depth. Generative AI has the potential to revolutionize numerous fields, from content creation to scientific research. By improving the efficiency and capabilities of generative AI through thermodynamic computing, Extropic could unlock unprecedented levels of creativity and productivity. This advancement could lead to the development of new applications that were previously thought unattainable, such as highly sophisticated AI that can autonomously generate complex designs in engineering or create original art forms. The potential for generative AI to impact society in profound ways is significant, and readers should consider how Extropic's innovations might accelerate this transformation. Conclusion. In summary, while the report provides an overview of Extropic AI's recent funding and technological advancements, it is crucial to delve deeper into the implications of their work. The concepts of out-of-equilibrium thermodynamics, the interdisciplinary nature of the team, the vision for autonomous systems, environmental sustainability, investor dynamics, and the future of generative AI all represent significant aspects that deserve closer attention. These elements not only highlight the uniqueness of Extropic's approach, but also point to a transformative shift in the computing landscape that could redefine our relationship with technology and the natural world. Understanding these nuances is essential for grasping the full impact of Extropic AI's innovations on the future of artificial intelligence and computing. 1. Innovative technological paradigm. Extropic AI is pioneering a novel computational paradigm that leverages out-of-equilibrium thermodynamics to enhance generative AI capabilities. Unlike traditional digital hardware, which often struggles with the probabilistic computations essential for generative AI, Extropic's approach aims to physically execute these computations. This innovation could potentially redefine how AI systems process information, making them more efficient and capable of managing complex probability distributions. The emphasis on thermodynamic principles signifies a fundamental shift in AI acceleration, moving towards a system that naturally integrates with the physical processes of the world. This could unlock new realms of efficiency that were previously unattainable with conventional computing methods. 2. Significant funding and investor interest. The recent $14.1 million seed funding round led by Kindred Ventures underscores strong investor confidence in Extropic's vision and technology. The involvement of high-profile investors, including notable angel investors from the tech industry, indicates a broad recognition of the potential impact of Extropic's innovations. This financial backing will not only expedite the development of their thermodynamic computing technology but also position Extropic strategically within the rapidly evolving landscape of AI hardware. The ability to attract such diverse funding suggests that the market is increasingly interested in alternative computing paradigms that can address the growing demands for AI computational power without a corresponding increase in energy consumption. 3. Expert team composition. Extropic is led by a highly interdisciplinary team with significant expertise in both AI and physics, including individuals with backgrounds at major tech companies such as Google, IBM, and NVIDIA. This unique combination of skills positions the company to effectively tackle the challenges associated with developing thermodynamic computing technologies. The leadership of Guillaume Verdon and Trevor McCourt, both of whom have extensive experience in quantum computing and AI, is particularly noteworthy. Their backgrounds not only lend credibility to Extropic's ambitious goals but also suggest a strong foundation for innovation in the intersection of physics and artificial intelligence. 4. Vision for the future of AI. Extropic's long-term vision extends beyond mere technological advancements. It aims to fundamentally redefine computing by embracing the natural entropy of the world rather than suppressing it. This perspective could lead to the development of self-organizing systems that autonomously learn and adapt, potentially transforming the landscape of generative AI. The company's goal is to achieve computational efficiency that scales generative AI applications without a corresponding increase in energy production, addressing a critical concern in the field of AI sustainability. This visionary approach resonates with broader trends in technology that prioritize efficiency and sustainability, positioning Extropic as a potential leader in the future of AI development. Here are 3 famous historical cases that exemplify revolutionary advancements in technology and innovation akin to Extropic AI's recent developments in AI accelerator chips. 1. The development of the transistor 1947. The invention of the transistor at Bell Labs by John Bardeen, Walter Brattain, and William Shockley marked a pivotal moment in the history of electronics and computing. This small device, which could amplify electrical signals and act as a switch, replaced the vacuum tube and led to the miniaturization of electronic circuits. The transistor enabled the development of modern computers, smartphones, and countless other technologies, revolutionizing the way information is processed and communicated. Its invention was foundational to the Silicon Revolution, paving the way for integrated circuits and microprocessors that now underpin virtually all electronic devices. The impact of the transistor has been profound, transforming industries and society at large, much in the way that Extropic's accelerator chips could potentially transform AI capabilities. 2. The launch of the Internet 1960s to 1990s. The development and commercialization of the Internet represent another monumental technological revolution. Initially funded by the U.S. Department of Defense in the 1960s through ARPANET, the Internet evolved over decades from a military communication tool to a global network that changed the way people interact, communicate, and access information. The introduction of the World Wide Web in the early 1990s by Tim Berners-Lee made the Internet accessible to the general public, leading to an explosion of online content, e-commerce, and digital communication. This paradigm shift created new industries and fundamentally altered the social and economic landscape. Similar to how Extropic's work could redefine computing paradigms and AI technologies. 3. The emergence of quantum computing 1980s present. Quantum computing is a cutting-edge field that has the potential to revolutionize how we process information. Pioneered by scientists such as Richard Feynman and David Deutsch in the 1980s, quantum computing leverages the principles of quantum mechanics to perform computations at speeds and efficiencies unattainable by classical computers. Companies like IBM, Google, and several startups are investing heavily in this technology with the aim of solving complex problems across various domains, including cryptography, materials science, and optimization. As Extropic seeks to create new computational paradigms through thermodynamic principles, the advancements in quantum computing illustrate how exploring fundamental physics can lead to breakthroughs in computing technology, showcasing the potential of innovative approaches to reshape our technological landscape. These historical cases highlight how fundamental innovations driven by new scientific insights and engineering breakthroughs can lead to transformative changes in technology and society, paralleling the potential impact of Extropic AI's accelerator chips in the realm of artificial intelligence. Future outlook, predictions for Extropic AI in the field of generative AI. As Extropic AI embarks on its ambitious journey to revolutionize generative AI through innovative accelerator chip development, the implications for the broader field of artificial intelligence are profound. Here are some predictions for the future of Extropic AI and the generative AI landscape over the next decade. 1. Transformation of computational paradigms. Extropic AI's approach to out-of-equilibrium thermodynamics will likely catalyze a paradigm shift in computing. By effectively utilizing natural entropy, we can expect a new class of computing systems that are not only faster and more efficient but also capable of handling the complexities of generative AI tasks that current technologies struggle with. This could lead to the emergence of novel computational architectures that will redefine how we understand and implement AI. 2. Enhanced efficiency in AI workflows. The promise of Extropic's chips lies in their ability to execute probabilistic computations physically, which could significantly reduce the time and energy spent on data management in memory. As these chips proliferate, we can anticipate a dramatic improvement in the efficiency of AI workflows, enabling organizations to run complex generative models in real time, thereby enhancing applications in fields such as content creation, drug discovery, and personalized medicine. 3. Increased accessibility of advanced AI. With the advent of more efficient computing technologies, generative AI could become more accessible to a wider range of industries and applications. Startups and smaller companies may leverage Extropic's technology to innovate solutions that were previously feasible only for tech giants. This democratization of AI capabilities could lead to a surge in creativity and innovation across sectors from entertainment to scientific research. 4. Accelerated development of AI research. The funding secured by Extropic AI is likely to stimulate further investment into research and development in the field of thermodynamic computing. As other organizations and academic institutions observe the potential of Extropic's technology, we can expect a ripple effect that will encourage more research into alternative computing paradigms, including quantum computing and neuromorphic computing. This collaborative environment could accelerate breakthroughs that further enhance AI capabilities. 5. Emergence of new AI applications. The unique capabilities of Extropic's accelerator chips may lead to the development of entirely new applications in generative AI that leverage physical processes. For instance, we might see advances in fields like virtual reality, where AI can create more immersive environments in real time, or in autonomous systems where AI can learn from and adapt to its environment more effectively. 6. Focus on sustainability. As concerns about energy consumption in AI systems grow, Extropic AI's emphasis on energy-efficient computing could prompt a broader movement towards sustainable AI development. Other companies may follow suit, prioritizing the design of systems that not only enhance performance but also minimize environmental impact. This could lead to the establishment of sustainability as a key metric in the evaluation of AI technologies. 7. New ethical paradigms in governance. As generative AI becomes more powerful and ubiquitous, ethical considerations surrounding its use will become increasingly important. Extropic AI's technology could spark discussions about the responsible use of AI, particularly as it relates to content generation and deepfakes. We may see the emergence of new frameworks for governance and regulation that seek to balance innovation with ethical responsibility. 8. Integration with other technologies. The development of Extropic's thermodynamic computing may lead to its integration with other emerging technologies such as blockchain for decentralized AI models or IoT for real-time data processing. This convergence could unlock new potentials in AI applications, enabling seamless collaboration between devices and systems across various domains. 9. Global collaboration and competition. As Extropic AI leads the charge in thermodynamic computing, global competition will intensify. Countries and companies will vie for leadership in this new technological frontier, fostering international collaborations while simultaneously driving advancements in AI research and application. This competitive landscape could accelerate technological progress but may also prompt geopolitical considerations regarding AI governance and security. 10. Long-term impact on society. Ultimately, the impact of Extropic AI and its revolutionary computing technologies could reshape society in profound ways. With the potential to enhance human creativity and decision-making, we might see a future where generative AI becomes an integral part of daily life, augmenting human capabilities in unprecedented ways. This could lead to a reimagining of work creativity and human-machine collaboration. Conclusion. Extropic AI's $14.1 million funding round marks a significant milestone not only for the company but also for the future of AI. As they push the boundaries of how we understand and utilize computation, the broader implications for generative AI are vast. Over the next decade, we can expect transformative changes that will enhance efficiency, democratize access, and redefine our relationship with technology. The journey ahead promises to be as exciting as it is unpredictable, with potential outcomes that could reshape the technological landscape for generations to come.